Welcome once again to our series today on the averages. So in our past series on the averages, we looked at different types of averages. We've looked at the arithmetic mean, we've looked at the harmonic, the geometric mean, we've looked at the weighted arithmetic mean, we've looked at the median. Today, we're going to be looking at the mode. The mode is simply the value that occurs the most in a set of observation. So for a probability distribution, the mode is simply the value of the variable that corresponds to the highest frequency. Also, for the continuous probability distribution, that is when the values are divided into intervals, okay, where they can take many values within those intervals. In that case, the mode is simply gotten from what is called the modal class, okay, using this interpolation formula stated clearly in equation 1. There are several advantages of the mode. Okay, one of them is that it is easy to compute. You can simply compute it by inspection. You can compute it graphically. Okay, it can be computed for open-end intervals. Now, this formula here helps us to calculate the mode when we have a continuous frequency distribution. Like I've said, I've explained what the continuous frequency distribution means. Okay, but there are conditions under which this formula holds. One of the conditions is that one, the data has to be a continuous data, that a data that can take on any value within a range. And then the second condition is that the width of each of these intervals must be equal. However, there are conditions under which this formula, this interpolation formula stated in equation 1 would be misleading. Some of those conditions for which this formula will not hold include one, when we have a multimodal case. That is when the mode, the highest frequency is occurring more than once. Another condition under which this would not hold is when the mode, when the highest frequency is occurring at the beginning or at the end of the distribution. Lastly, this formula will still not hold when the frequencies are increasing or decreasing in haphazard manner, that is scattering. This expression in equation 2 is what helps us to calculate, is what gives us rather a better representation of the mode when those conditions I just stated happen. Basically, when the mode is multimodal. Okay, this equation 2 helps us to get a better representation of a mode. And again, it helps us when we have the multimodal case, and it also helps us when we have when the set of data is such that the distribution is asymmetric. Asymmetric in the sense that when it is plotted, the graph is not equal on both sides. That is when it is skewed, it is not symmetric. So that is a case where we are supposed to use the equation 2. Let's see how we can illustrate the use of this formula stated in equation 1 to solve for the mode of a given set of data, illustrating the continuous probability distribution case. Okay, let's solve by creating what is called our class boundary. Now, the L here in this our formula for mode, the L here stands for the lower class boundary of the modal class. Remember I said the mode is gotten from the modal class, right? The H here stands for the width of the modal class. The F1 here stands for the frequency of the modal class. The F0 here stands for the frequency of the class before the modal class. The F2 here stands for the frequency of the class after the modal class. We get our class boundary by, from a class interval here. So it's by way of it's by way of removing a 0.5 here and adding a 0.5 here. So over here, when we remove a 0.5, we have a 20.5 to 22.5. Then lastly here we have 28.5 to 30.5. So this right here is our class boundary. Now let me explain this data to you. This data is simply a data on the production of a particular commodity with respect to dates. Okay, so this production here is in terms of tons, is measured in tons. Okay, so for 7 days, the production is between 21 to 22 tons. For 13 days, it's between 23 to 24 tons. And it goes down to 8 days, they had 29 to 30 tons. So we want to get an average to describe this production. We want to get an average description of the production, okay, using the mode. And then because it's a continuous frequency distribution case, is the reason why we are using our interpolation formula here by way of our class boundary. So from the class boundary here, now the number of days here is representing the frequency f. Okay, so we remember we said the mode. Okay, it's simply for the continuous frequency distribution. The mode is simply gotten from what is called the modal class. The modal class is that class that corresponds to the highest frequency, right? So now the highest frequency here is a 22. So when you trace it back here, let's take it to a class boundary here. So clearly, our modal class is 24.5 to 26.5. So this is our modal class. So now we can go back to insert everything we need here from here. Okay, so let me write this on the pad. So now from here, our L value now Remember, L is the lower class boundary of the mother class. The lower class boundary is this 24.5. So this is 24.5 plus our H is the width. The width here is 2, from 1 to 22, from 23 to 24. That's 2, okay? Times the frequency of the mother class is 22, okay? The frequency of the class before the mother class, this is the class before the mother class, the frequency is 13, okay? Over the same thing here, 22 minus 13 minus, and then the frequency, F2 here stands for the frequency of the class after the mother class. So the class after the mother class is this class, and the frequency is a 10. So we have a 10 minus the frequency of the mother class, of course, which is 22. So from here, we can move further and simplify our expression. So I'm going to take off this part. So we now have 24.5 plus 2 times this minus this will give us a 9 all over. This minus this is a 9 minus this will give us a minus 12. Minus becomes a plus 12, okay? So this is 24.5 plus this times this is an 18 all over this plus this. It's simply a 21. Here we have 24.5 plus 0.857. This is gotten by dividing this by this. And when we add it, we have our mode approximately equal to 25.36. So this is 25.36 tons. So this right here is an estimate of the average production, the average daily production using the mode as our measure of average. I hope you guys have learned something today. I'll see you guys in the next video. But before then, please like my video, share my video, comment on the video, follow me for more videos. Bye bye. Love you.